This video will work through problem 14.9 of Gapenski's Healthcare Finance, 6th edition. This is actually a pretty straightforward NPV kind of problem. So I'll do it manually here first, and then maybe I'll switch over to Excel. So we've got a project that is going to cost us $100,000 to start. And then in years 1, 2, 3, 4, and 5, it's going to earn 30, 30, 30, 30, and 30. And then, according to the book, it then has a salvage of 20. So this is 20,000. These are all thousands, right? And then 20,000. I'm just not going to write the zeros. So a total in year 5 of 50. And then the questions are, what's the project's IRR, its MIRR, and then what is its NPV? So I'll start by using a financial calculator to do this. So to answer the, let's answer the IRR and the NPV first, and then we'll do MIRR. So I'll go a little out of order from the text. Okay. Let's turn this on. I'm going to make sure we clear our TVM. So using the TVM, we have an N of 5. If we're going to do IRR, we have an unknown interest rate. The PV is 100,000. I'll go ahead and I'll actually put in the thousands. So our PV is 100,000. And then we have payments of 30,000. And then we have a future value. So the salvage value can be treated as a future value of 20,000. And then you just hit compute interest rate per year. And we get, this is equivalent to the IRR. So it's going to be 19.05. Okay, another way to do this with the financial calculator is to use the cash flow register. So let's just, okay, so it's not cleared. So we're going to clear our cash flow register. So our CF0 is 100,000 negative. Enter, down. Our CO1 is 30,000. Enter. And we get 30,000 1, 2, 3, 4 times. So our FO1 is 4. Then our CO2 is 30 plus 20 is 50. And we get that 1 time. So then we hit IRR and compute. And we get 19.05 again, right? So the IRR is 19.05. That's 2 different ways to calculate the IRR. The NPV, since we're using the cash flow register, we can do it this real quick. We'll do it this way first. The NPV, we need our discount rate. And so the average discount rate for this project is given to us as 10%. So cost of capital is 10%. So we hit 10, enter, and then compute NPV. And we get an NPV of 26,142. Okay, so our NPV, 26,000. So IRR is 19.05%. NPV equals 26,142. All right, so to do the MIRR, we need to, with the calculator, we need to bring all these payments to the future, right, and get the future value of all these payments. So this is really, we can ignore the 20,000 in salvage for a moment and treat this as a 5-year future value of an annuity. So we start with the payments of 50,000. And I'll make them negative because, sorry, not 50,000, 30,000. And I'll make them negative so that way I get a positive future value. This is a bit of calculatorology, right? So negative because they're being invested, and then there'll be a positive number at the end. So that's 30,000 for our payments. Our N is 5. or our number of years is 5. Because we have a 10%, yeah, 10% cost of capital, we're going to assume that our reinvestment rate is 10%. So we're going to set our I per Y at 10%, and then we're going to calculate the future value. So, sorry, future value, 10 for the I, future value, compute. Thanks to the magic of stop action recording, we'll do that one more time. So future value, compute, is 183. So our future value of these cash flows is 183, 153. And then we're going to add 20,000 so that the future value is 183 plus 20,000 is 203, 153. So the future value of all this is 203, 153. We want to now find the interest rate that, if we applied it as a discount rate, would bring this back and make it equal to 100,000. So what would that be? Well, we set the 203. So we're going to clear our TVM. We're going to set that as our FV. We want a PV of 100. We have 5 years, and we just say compute interest rate per year, and that's 15.2%, which is our MIRR. Okay, so now we've got the MIRR, sorry for the messy writing, is 15.2%. Okay, so then we can, let me see what else we've got here. So right now, given that our cost of capital is 10%, our IRR and MIRR both exceed the cost of capital, so that says that this project is a go. The NPV is greater than 0, so that tells us that it's a go. Right, and those are kind of two sides of the same coin, right? If the IRR hadn't said it was a go, the NPV wasn't going to say it was a go. So the project should be a go. And then let's switch now to doing Excel, especially since we're going to mess around and do some scenarios. Okay, so now using Excel, first let me redo parts A and B. So we have year, and we have 0, 1, 2, 3, 4, and 5. We have our cash flows of minus 100, 30, and then 30 all the way down, right? And then we have a salvage value of 20. I'm going to put it over here just because that's how I feel like doing it. And then we can do a kind of a total cash flows. So, okay. So first question was, what's the IRR? And we get 19% again. What's the MIRR? And so we're going to do the values first. Then it wants the financing rate, which is 0.1, 10%. And then it wants the reinvestment rate, which is also 10%. So we got it 15%. We can get a little more granularity on this. So that gets us, well, what did I say? I said 19.04 for the, so 19.05. Okay, so there's our first two answers. And then our NPV, right, is equal to the sum of the initial investment plus the present value at 10% of these cash flows and, you know, because I did this in thousands instead of, or I dropped the thousands, so that's 2614, which should be 26,142. But so just multiply that by 1,000. There you go. There's your 26,142. We can also kind of do the manual way that I like to do this. So we could have the PV of the cash flows. And so this one is what it is because it's happening at the present time. This one is being brought back. Oh, let me punch in my cost of capital as 0.1. So this will be our IRR. Well, it's really our cost of capital, but it's going to become our IRR. And we'll just do 30 divided by 1 plus the discount rate raised to the number of years. And that gives us our present value formula and respective. So here is our NPV. It's just the sum of that column. And so you can see, again, we match up. If we were to multiply that by 1,000, we'd get 26,142. Just like we did when we did it using the NPV formula. And then to manually calculate the IRR, we can, it'll become this, right? So we use the goal seek, what if analysis, goal seek. We're going to set the NPV equal to 0 by changing the cost of capital, which will become our IRR. And so our IRR goes to 19.05%. So there you go. That's another, so that would be the IRR. That matches up with this IRR. So there's a couple of different ways of doing things. And then finally, for the MIRR, we want the future value of the cash flows. And so we're going to take these $30,000 payments into the future. So this is going to equal, so we need our reinvestment rate to go back to 10.10. And so the future value of these cash flows is going to, because this now becomes our reinvestment rate. So we take the $30,000 cash flow and bring it into the future by multiplying it by 1 plus the reinvestment rate raised to the number of years it's going forward. So how many years is it going forward? It's going forward 1, 2, 3, 4, right? So that's going to be 5. There's a total of 5 years, but this is happening at year 1. So 5 minus the year that the cash flow is received will get us 4 in this case, which is the number of years it's actually going forward. And then we can just copy that down. And our total future value is the sum of those payments, the future value of those payments. And now we need to know what interest rate would bring us back to 100,000. So I'm not aware of a formula that'll get us the answer to this. So I'm just going to do it manually. So the answer would be based on the present value formula. We've got a future value is equal to the present value times 1 plus the interest rate raised to the n. So in this case, we've got, we would then divide both sides by the present value. So that divided by 100 raised to the 0.2 minus 1 will give us 15.2, which, as you can see, is the same as our MIRR. So that's just doing it very manually, really manually there. Okay, so that's doing the problem kind of for all these variations, both in writing and and then in Excel, so both in using the calculators and then in Excel. All right, so part C has us making some assumptions about changes. So the payments could be as low as 20,000 or as high as 40,000, and then the salvage value at the end of year 5 could be as low as 0 or as high as 30. What are the worst and best case, worst case and best case IRRs, and the worst case and best case NPVs? Okay, so our worst case scenario would have, let's see, how do we want to do this? I'll just do it here. So worst and then best, what are our assumptions? Well, cash flow. So best, worst and best, we still have the same initial investment for both. And then for the worst case scenario, we're going to get $20,000 per year. And part of the worst case scenario would be the idea that we would get a 0 salvage value. So that makes that easy. And then the best case would be that we get $40,000 per year. Right. And then we would get a salvage of 30,000. So this would actually be 40 plus 30 or 70. So there's your worst, there's your best. So let's do, what's it ask us to do? IRR and NPV. Okay, so let's give this one more. So IRR would equal IRR there's our IRRs. Let's see if we get a little more detail here. So it's 0 IRR. So that's not good. And then our NPV, I'm not going to do it all kind of 47 different ways I've been doing. I'm just going to do it real quick. So it'll be our investment plus the present value of the cash flows at our 10% discount rate, which is negative 24,000. So if we just, bring this out to 24,184. So that is negative 24,184. And then I think we can just copy that over here. And a positive 70,259 would be the best case scenario. Let's give this a little more detail. So it's really 32.64. Okay, so positive 70,000 or to negative 24,000. Okay, so that is part C.